This is section 4.1, linear functions. So everything we do in this section is going to be a review. So I'm just going to go through these problems very quickly and do problems that are similar to what I'm going to assign for homework. These are all problems from the textbook. So the first set of problems you're doing is determining whether the equation of the curve can be written as a linear function. So we're looking at this right here and deciding, is this linear? So remember, to be linear, you have to be able to write it in the form y equals mx plus b. And if you can't, then it's not linear. So some of the things that you're looking for are right here. So because the x is squared, this is not linear. Other things you're looking at that are not linear is x cannot be in the denominator. You can't multiply variables, like you can't have something like x times y and have it be linear. So you need to be able to write it in this format in order to make it be linear. You also can't have a variable underneath a radical. So again, just as a reminder, different things that can, that make it not linear, to be linear has to be in this form. So then you are asked about whether or not the function is increasing or decreasing. Okay, well, think about what increasing means. As you move from left to right, it's increasing. So it's the y values. As x gets larger, y gets larger. So that's going to look like this. Decreasing. As x gets larger, y gets smaller. So that's going to look like this. So for linear functions, we're just looking at the slope. So is it a positive or a negative slope? All right, so here is our slope. It's the coefficient of the x term. So we have a negative slope, so that means this is decreasing. Here we have a positive slope, so this one is increasing. Next, you're going to be asked to find the slope of a line that passes through given points. So remember, to find the slope, it's the change in y over the change in x. That's like delta y over delta x. Or we have this formula from algebra, y2 minus y1 over x2 minus x1. So I'm going to subtract 2 minus 4. And if I start with a 2 in the numerator, then I have to start with a 5 in the denominator. 5 minus a negative 1. So I end up with a negative 2. That's going to change to adding the opposite. So we're going to get a 6. So I get negative 1/3 when I simplify that. Now I'm asked to actually write the linear equation that satisfies the condition if possible. So 34, you probably won't have well, let me just write down your two possibilities. So we're talking about y equals mx plus b. You need to write it in this form. Or I like this version, y minus y1 equals m times x minus x1. I don't care which version you use. If you want to use the slope-intercept form, or if you want to use the point-slope form, either way. So what this means, though, in this one, the notation's a little different, so I wanted to do one like that. This is in function notation, so this is the x value. So this is saying f of x, f of negative 1. So when x is negative 1, f of x is 4. That's what that's saying. So that gives us the point negative 1, 4. This gives us the point 5, 1. Now you're going to find the slope and then use it to find the equation of the line. So I'm going to do 1 minus 4 over 5 minus negative 1. So I get negative 3 over 6, which is negative 1/2. That's the slope, but I'm not done yet. Then I have to use one of the points. I'm going to use point-slope form. So I think I'll use this point. So this becomes my x1, this becomes my y1. So y equals negative, So we get y minus y1, which is 1, equals negative 1/2 times x minus 5. And then I'm going to simplify that. So distribute, which makes this a positive 5/2. And then I'm going to add 1 to both sides. So adding 1 is the same as adding 2/2. So I get 7/2. So here's my equation. And this one, I have the 2 points. I'm going to find the slope. So I get 6 minus 8 over 4 minus negative 2. So I get a negative 2 over 6. We get a lot of negative 1/3 here for slopes. Then I'll use, well, I still like the point slope form, so I'm going to use that one. Y minus, I'm using this point, y minus 6 equals negative 1/3 times x minus 4. And simplify this, so I'm going to distribute, so I get negative 1/3 x. It's going to make this a positive 4/3. Then I'm going to add 6 to both sides. So if I change that to, so I have 4/3 plus, if I change the whole number 6 into thirds, I'm going to have 18/3. So I get 22/3. So there's my answer. Okay? Hopefully I'm going fast, so there's always that chance I make a careless mistake. So hopefully if I do, somebody will point that out to me and I can fix it. So again, I know I'm going fast. If you need to pause and rewind, go ahead. You also have examples in your textbook. This is all review. I just want to kind of get your brain thinking about these types of problems again. All right, so here we're asked, determine whether the lines given by the equations below are parallel, perpendicular, or neither. So what do we need to know? Well, we need to know that parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. So we got to see what the slopes are. So I'm going to solve each of these for y. So for the first one, I'll have negative 9y equals negative 6x plus 10. Then if I divide everything by negative 9, I'm going to get 6/9 x minus 10/9, which will simplify. I have this tendency to be writing uphill, which would simplify. 3 goes in 2 times, so we get 2/3 x minus 10/9. So now we have to see what the slope is of the other one. So we get 2y equals negative 3x plus 1. And if I divide by 2, then I could see that I get a slope. So here my slope is negative 3/2. Here my slope is 2/3. Opposite and reciprocal. So these are perpendicular lines. If they had been the same slope, I would say parallel lines. And if they were neither one of those, I would say neither. All right, next we're asked to find the x and y intercepts. So to find the x-intercept, let y equal 0 and solve for x. To find the y-intercept, let x equal 0 and solve for y. So here, if I let x equal 0, then I get 2 times 0 plus 4. So my y-intercept is 0, 4, which that's easy to see because it was in slope-intercept form. So to get the x-intercept, let y equal 0, which is really g of x. So I have 0 equals 2x plus 4, and solve for x. So we get x equals negative 2. So my x-intercept, and I prefer ordered pairs when you write these. So there's my x-intercept. This is in slope-intercept form. This one is in standard form.
Pardon the interruption real quick.
Okay, so remember standard form looked like this. Ax plus by equals c, if you remember that. I like this for x and y intercept because if you let x equal 0, remember the cover up? I'm not going to cover it up. I'd put my hand over that if I were here. But we get y and then solve for y. So you're just doing 56 divided by 2 when we get so we get 28. So that means the y-intercept is 0.28. And if you let y equal 0 and you cover up that part, then you're going to get x equals 8. So the x-intercept is 8, 0. So we have the x and y intercepts. And then if we had to graph these, you could use the intercepts to graph them. Okay, for the next one, we're asked to write an equation for a line perpendicular to a given line that passes through a particular point. So again, it's perpendicular, so we have to think about what does that mean about the slope. So remember opposite reciprocal slope. And so I'm going to look here and I see I have a slope of -2, but that's not the slope I want. I need to change the sign and flip it, so it's going to be a positive 1/2. And now I am done. I don't care about this. I am done with h of t. I'm done with that equation. Now I need for this slope of 1/2 that passes through this point, and I'm going to use y minus y1 equals m times x minus x1. And I get y minus a -1, so be careful with your negative signs, equals m times x minus -4, makes that a +4, and then you distribute. So we get 1/2 x, half of 4 is 2, and then subtract 1. And that is the equation of our line. Next, find the slope of the line that's graphed. Okay, just the only caution I would say on this is make sure that when you're counting boxes that you pay attention to the scale. So this one's pretty easy to see. You can see that here's a point here and it looks like a point here. I can see the intercepts. So it looks like I'm going down 5 and over 4. So I get a slope of -5/4. Make sure that you look at the line in case you just count 5 and 4 and write down 5/4. The line is decreasing, it's going down from left to right, so I know it's a negative slope. So just kind of always check that so you don't make a careless mistake. So this one, similar, except it says now write an equation for the line graphed. So, so I need to know the slope and the y-intercept if I want to just do that. That'd be the easiest, if I can tell what they are. Sometimes you can't tell. Sometimes you have to pick out 2 points on the graph and do the method, like find the slope, because sometimes it's hard to tell from the graph. But here, I'm pretty sure the y-intercept is 3, and I can see that it passes through this point right here. So it looks like I have a slope of -2. So the slope is -2, and the y-intercept, which we call b, is 3. So I get y equals -2x plus 3. Doesn't get much easier than that. So next we're asked to sketch the graph. So if we do that, draw in my axes. So I picked this one because it's backwards from what you normally think of. And also this would be the t-axis and this would be f of t. So it doesn't have to be x and y. But don't fall into the trap and think, well, the first thing is the slope and the next thing's the y-intercept. No, the coefficient of my variable is the slope. So here's my slope. And this is my intercept. And it would be my f of t intercept. So it's where it crosses that axis. You should always scale your graph, so I'm going to count by ones. So then my intercept is 3, my slope is 2, so I'm going to go up 2 and over 1. Or you could go down 2 and to the left 1, because that would be a negative and a negative. And then you can draw in your line. Okay? And I think this is the last problem. When temperature is 0 degrees Celsius, the Fahrenheit temperature is 32. When the Celsius temperature is 100, the corresponding Fahrenheit temperature is 212. Express the Fahrenheit temperature as a linear function of C, the Celsius temperature, f of C. So that's kind of a lot. But you want to determine, okay, so this is like setting it up like C and f of C. So instead of an x, I have a C, and instead of a Y, I have an F of C. So if you're comparing, to what you're familiar with, most familiar with. So if the temperature is 0 Celsius, that's 32 degrees Fahrenheit, and 100 is 212. And I'm assuming you know what's special about those numbers, because 32 degrees Fahrenheit is freezing and 212 degrees Fahrenheit is boiling. So that's those are your conversions there. So we want to find the rate of change in part A for each unit change of temperature of Celsius. So basically that's rate of change is like asking you to find the slope. And this is, I have 2 points, 0, 32, and 100, 212. So I'm going to take my rate of change. So I'm going to take 212 minus 32 over 100 minus 0. So when I do that, I get 9/5. So what does that mean, and how would we interpret that? So what I would say is for every increase in degrees Celsius, the Fahrenheit increases because it's positive by 9/5. I was going to say of a degree, but I should say degrees. It's bigger than 1. Okay, so when you so this is this for each increase, for every increase in degrees Celsius, for every increase of 1 degree, really that would be for every unit increase. Let's put in the word unit. For every unit increase in degrees Celsius, when you increase the degrees Celsius by 1, that would be equivalent to increasing Fahrenheit by 9/5. So that's how you would interpret that rate of change. Part B asks us to find and interpret F of 28. So that's telling us to plug in, what would we do? Well, actually to do that, we need to come up with an equation. So we're going to do that first. Well, it's actually pretty easy because we know the slope is 9/5. And look right here, 0, 32. That's the intercept. So we know the intercept, or the constant, is 32. So we get, and I'm going to write this in this term, so we have F of C equals the slope, so 9/5 C instead of an X, plus 32. And that's actually our equation. So now if we want to know what F of 28 is, we're going to take 9/5 times 28 and add 32. So we get, and that would be awkward really, because who's going to say that? What's the temperature? 412 divided by 5. So let's see what that is and just kind of approximate that. So we get 82.4. So this would be 82.4 degrees Fahrenheit. So find and interpret. 28 degrees Celsius is equivalent to 82.4 degrees Fahrenheit. Part C is asking us to find and interpret this. So now we're going to plug in, instead of a 28, I'm going to do second, oops, that was the wrong place, one more here. Second insert and put a negative sign in there. And then if I type over that, I think it will work, 40. And I get negative 40. Weird. So that means that negative 40 degrees Celsius is equivalent to negative 40 degrees Fahrenheit. How unusual. And that would be the only, because this is a linear function, that can only happen one time. That would be the only place where that would occur, where the two different measuring devices, measuring units of measure are actually going to be equal to each other. So that gives you some examples from this section. You should be able to do the assignment.